Welcome back, dear viewers, to the Stellar Twin Voyagers program. Today, I, Nova A239, will guide you once again in exploring the journey of two siblings striving to fulfill their colorful dreams. Let us together explore the eternity of a million ages amidst the sea of stars. Get ready to be mesmerized by the wonders of the universe and stories full of hope that will inspire us all. The break time is over, and the clock now shows 1:30 p.m. Grandpa, Dad, and several other farmers return to the stage to take turns giving guidance on seedling techniques, plant care, pest prevention techniques, and much more. The villagers listen attentively to the explanations being given. Meanwhile, Aster and Cosmo are busy with the books given by Grandpa, reading page by page and quietly discussing them. Grandpa and Dad smile seeing their grandson's understanding and enthusiasm in delivering guidance to the villagers. At the end of the session, Grandpa and the outreach team open a Q&A session for the attending farmers. There is enthusiasm among the audience, and various questions are posed to Grandpa. Grandpa and the other members of the outreach team slowly respond to these questions. Before they know it, it's already 5 p.m. and time to conclude the event. All right, everyone, announces Grandpa, I feel deeply honored and very happy to have been able to provide guidance today alongside the outreach team regarding superior seedlings and techniques for planting and plant care. Especially seeing the enthusiasm from the farmers and villagers gathered here, we feel greatly appreciated and committed to providing better outreach guidance in the future. Well then, I think that's all for today. Thank you for attending today's outreach event. See you another time. Please disperse and go back home. The villagers applaud warmly, then gradually begin to disperse and head home. Dad and Grandpa walk over to where Aster and Cosmo are sitting. They are engrossed in reading and haven't realized the event has ended. Aster, Cosmo, Dad says, let's go home. The event has ended. It's getting dark too. Aster looks up and says, oh, Grandpa, Dad, the event is over already. Sorry, we didn't notice. It's okay, let's go home now. Don't keep Mom waiting too long, Dad says, handing them warm outfits. All right, Dad, Aster and Cosmo reply. They then get on their Dad and Grandpa's bikes, and Dad and Grandpa start pedaling home. As they are almost home, Aster suddenly says, Dad, please drop me off here. Cosmo, we haven't taken our sheep grazing yet. Oh right, that's true, Cosmo responds. Grandpa smiles and says, all right then, let's go to the sheep pen first, and then we'll all go home together. Okay, Grandpa, Aster and Cosmo say in unison. Dad and Grandpa pedal towards the sheep pen, and once there, Aster and Cosmo open the pen door and lead their sheep out to the pasture. After their flock grazes and drinks water, Aster and Cosmo bring their sheep back to their pen. Then, together with Dad and Grandpa, they head home. Mom, we're back, Aster says as they arrive at the front door. Ah, you're all back. I've prepared dinner. Come on, clean up first. We'll eat together, Mom says while tidying up the kitchen. Okay, Mom, Aster and Cosmo say as they head to their room to change clothes. They take turns using the bathroom at the back of the house with Dad and Grandpa. After everyone finishes cleaning up, they sit together at the dining table ready for dinner. Bon appetit, and they all enjoy their dinner happily. After dinner, Grandpa whispers, let's quickly help your mom. Tonight, we'll witness something special in the night sky. Aster and Cosmo nod eagerly and immediately start helping to clean up the dishes, while Dad and Grandpa wait in the front yard. After Aster and Cosmo finished, they immediately ran towards their father and grandfather. Seeing their two sons, father quickly handed back their warm clothes. Here, put these on, let's start walking to the meadow. As they walked, Cosmo asked, Grandpa, Father, what special event are we observing today? The lunar eclipse, Cosmo, father replied. Right, grandfather added, and I will also explain various aspects about how eclipses occur. Wow, exclaimed Aster in surprise, it seems like it's been quite a while since we last observed a lunar eclipse. Today's the day then, a lunar eclipse. Exciting. Seeing their enthusiasm, father and grandfather smiled at each other. Shortly after, they reached the meadow. Father quickly laid out the mat and they all sat down. When is the eclipse, Grandpa? Aster asked eagerly. About 40 minutes from now, let's relax while Grandpa explains to you about the eclipse, grandfather said. Grandfather began, yes, there are some important terms you need to understand first. Conjunction, occultation, syzygy. First, conjunction. Conjunction occurs when two astronomical objects, such as planets or stars, appear close to each other in the sky from Earth's perspective. Conjunctions can provide a great opportunity for amateur and professional astronomers to observe and photograph objects that are usually far apart in the sky. For example, the conjunction of Jupiter and Saturn in December 2020, known as the Great Conjunction, was a rare and spectacular event. Conjunctions between planets can occur several times a year depending on the planets involved. Outer planet conjunctions, like those between Jupiter and Saturn, occur once every 20 years. Then there's occultation. Occultation occurs when one astronomical object passes in front of another, hiding it from view. For example, the occultation of a star by the moon or the occultation of a planet by the moon. Occultations can be used to study the atmosphere of the occulting object, such as when a planet or the moon covers a star, allowing scientists to measure changes in light and gain information about the atmosphere or shape of the object. Occultations by the moon occur quite frequently because the moon moves quickly across the sky. Occultations of planets by the moon or occultations of other objects are rarer and depend on the orbit paths of those objects. Next is syzygy. Syzygy is the term used when three astronomical objects are in alignment. A common example is when the sun, Earth, and moon are aligned, causing a solar eclipse or lunar eclipse. Solar eclipses and lunar eclipses are direct results of syzygy. Solar eclipses can significantly affect local lighting conditions and temperatures during their occurrence, and they have high educational and research value. Syzygy also causes more extreme tides, known as spring tides, when the gravitational forces of the sun and moon work together, resulting in the highest high tides and lowest low tides. Solar and lunar eclipses occur several times a year, but their viewing locations vary. Spring tides occur twice each lunar month, around the time of the new moon and full moon. Perhaps grandfather will explain occultation in more depth before discussing the eclipse. Occultation, as grandfather explained earlier, is an event where one astronomical object passes in front of another, hiding it from view. Occultations can be used in astronomical measurements for various purposes, such as measuring size, shape, atmosphere, and even discovering unseen celestial objects. First, occultation of stars by asteroids or the moon. When an asteroid or the moon passes in front of a star, observers on Earth can record the time the star disappears and reappears. Using data from various observation locations, scientists can map the shape and size of the occulting object. Occultation by an asteroid can also reveal irregular shapes of the asteroid. Second, occultation of planets or stars by the moon or planets. When a planet or the moon covers a star, the starlight passes through the object's atmosphere, if any. Measuring these light changes can provide information about the composition, temperature, pressure, and structure of the atmosphere. For example, occultation of a star by Titan, Saturn's moon, can provide data about its thick atmosphere. Third, occultation by the moon. Observing occultation by the moon can be used to refine the positions of stars very accurately in star catalogs. For example, observing occultation of stars by the moon can improve star positions in catalogs like Hipparcos. Fourth, occultation of stars by giant planets. Occultation of stars by giant planets like Jupiter or Saturn can reveal the presence of rings or small satellites that are difficult to see directly. For instance, occultation of a star by Neptune can indicate the presence of thin rings that are hard to detect with telescopes. Fifth, occultation of stars by Kuiper belt objects (KBOs). Observing occultations by objects in the Kuiper belt can provide information about their orbits and velocities. For example, occultation by Pluto has provided detailed information about its thin atmosphere and orbit. Sixth, search for small planets or comets. Occultations can assist in detecting small celestial objects such as minor planets or comets that are not visible with regular telescopes. For example, several KBOs and other trans-Neptunian objects have been discovered through occultation. Oh, there's one more term, elongation. Elongation is the angular separation between the Sun and a planet or moon as viewed from Earth. Elongation is a parameter used to describe the relative position of a planet with respect to the Sun. Maximum elongation occurs when a planet is at its furthest point from the Sun in the evening sky. This means the planet is at its greatest apparent distance from the Sun in its orbit as seen from Earth. Maximum elongation allows observers on Earth to clearly see the planet in the night sky. Now grandfather will start explaining about eclipses, but grandfather is thirsty. Grandfather will drink first, okay. Ah, now it's father's turn to show off. Father suddenly said, ha ha ha, listen to father's explanation while waiting for your grandfather to rest. Solar eclipses and lunar eclipses are two astronomical phenomena that occur when one celestial body moves into the shadow of another celestial body. First, solar eclipse. A solar eclipse occurs when the moon moves between the Earth and the Sun, thereby obscuring some or all of the Sun's light reaching Earth. This can only happen during the new moon phase, when the Sun and moon are in conjunction in the sky. There are several types of solar eclipse. First, total solar eclipse. This occurs when the moon's disk completely covers the Sun's disk. It is only visible from a small area on the Earth's surface that lies within the path of totality. For a few minutes, daytime turns dark as if it were night. Second, there is partial solar eclipse. This occurs when only part of the Sun's disk is covered by the moon. This eclipse is visible from a larger area compared to a total eclipse. Then there's annular solar eclipse. This occurs when the moon is too far from Earth to completely cover the Sun. The moon's disk covers the center of the Sun's disk, leaving a bright outer ring called the ring of fire. There is also a fourth type, hybrid solar eclipse. This is a combination of a total and annular eclipse. In some parts of the eclipse path, it appears as a total eclipse, while in other parts it appears as an annular eclipse. There are also several terms you should know about solar eclipses. First, umbra. This is the dark central shadow region where a total eclipse is experienced. Second, there's penumbra, which is the lighter shadow region surrounding the umbra. This area experiences a partial eclipse. Then there's antumbra. This occurs when the moon's disk is not large enough to cover the entire Sun's disk, resulting in an annular eclipse. Next, father will explain about lunar eclipses. Lunar eclipses can occur when the Earth moves between the Sun and the moon, causing the Earth's shadow to fall on the surface of the moon. This can only happen during the full moon phase, when the moon is on the opposite side of Earth relative to the Sun. There are several types of lunar eclipse. First, total lunar eclipse. This occurs when the entire disk of the moon enters the Earth's umbra. The moon often appears red or coppery during this eclipse, known as the blood moon, due to sunlight passing through Earth's atmosphere and bending towards the moon. Second, partial lunar eclipse. This occurs when only part of the moon's disk enters the Earth's umbra. Part of the moon will appear darkened. Third, there is penumbral lunar eclipse. This occurs when the moon only enters the Earth's penumbra. This eclipse is difficult to observe as it only causes a slight dimming of the moon's brightness. There are also several terms related to lunar eclipse. First, umbra. This is the dark central shadow region of the Earth. The part of the moon within the umbra experiences total or partial eclipse. Then there's penumbra. This is the lighter shadow region surrounding the umbra. The part of the moon within the penumbra experiences penumbral eclipse. Solar eclipses occur about 2 to 5 times per year, but total eclipses only occur once every 18 months somewhere on Earth. The duration of totality is usually only a few minutes. Meanwhile, lunar eclipses occur 2 to 4 times per year. Total lunar eclipses can last up to 3.5 hours, with totality lasting about 1 hour. However, Aster, Cosmo, eclipses do not occur every month because the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the Sun, the ecliptic. Eclipses only occur when the moon is near one of the 2 points in its orbit called nodes, where the moon's orbit and Earth's orbit intersect. Yes, that's correct, continued grandfather, taking over from father's explanation, and the phenomenon of eclipses itself also serves many purposes. For example, the occurrence of a solar eclipse can help scientists study the sun's corona, which is usually hidden by the sun's bright light. It can also help test the theory of general relativity through observations of starlight bending. Meanwhile, lunar eclipses can provide information about Earth's atmospheric composition through observations of the color and intensity of light reaching the moon. It can also assist in determining the size and shape of the Earth's shadow. Well, it's truly amazing, Aster exclaimed. And father continued, there's something equally fascinating about this phenomenon. Now it's father's turn to explain to you about exoplanets. Exoplanets are planets that orbit stars outside our solar system. Here are some unique ones. First, there's a lava exoplanet named 55 Cancri E located about 40 light-years from Earth in the Cancer constellation. This planet is estimated to have a surface that is extremely hot and filled with lava, possibly with an atmosphere rich in elements like silicon dioxide and titanium oxide. Then there's the iron-hot exoplanet named WASP 76b located about 640 light-years from Earth in the Pisces constellation. Its surface has a very high temperature, around 2,400 degrees Celsius. It's also referred to as the iron-emitting planet because its extreme temperature conditions allow iron to vaporize and be seen in vapor form in its atmosphere. Next is the sunken exoplanet named Trace 2b, the Black Bat. This planet is located about 750 light-years from Earth in the Draco constellation. Its surface is extremely dark, absorbing about 99% of the light that hits it. This is due to its dense atmosphere, which prevents light from its parent star from reflecting back into space. There's also an ice exoplanet named Ogle 2005b LG390lb located about 21,500 light-years from Earth in the Sagittarius constellation. Its temperature is very low, estimated to be less than -220 degrees Celsius. It's called ice because it's believed to be composed of ice and gas, unlike typical giant gas planets. Next, there's the golden cloudy exoplanet named HD 189733b located about 63 light-years from Earth in the Vulpecula constellation. This planet has an atmosphere believed to be dark blue in color, filled with small particles made of silicon and heavy metals like titanium and nickel, creating a spectacular golden color effect. Let father think again. There's also the jewel rain exoplanet named PSRJ 17191438b located about 4,000 light-years from Earth in the Serpens constellation. This planet is believed to be composed of condensed carbon, like diamonds and other gems. Its temperature is extremely high, causing materials in its atmosphere to crystallize and rain down as jewel rain. There's also the black carbon exoplanet named WASP-12b located about 870 light-years from Earth in the Auriga constellation. Its surface is covered by an atmosphere layer containing oxidized carbon. This carbon absorbs light, making the planet appear very dark with a very low albedo. Yes, Father can't think of any more examples for now, but regardless, isn't it all very fascinating? The two children nodded. Look, the eclipse has started. Let's enjoy it, Grandfather said, pointing to the moon. Wow, indeed, the moon is beginning to look bitten, Cosmo said. The four of them enjoyed their time observing the lunar eclipse that night, exchanging stories and singing beneath a sky full of stars. That concludes today's episode of the Stellar Twin Voyagers. Fun, isn't it? Would you like to hear more amazing stories from our young shepherd boys as they write their tales among the millions of pearls in the night sky? Therefore, stay with us on this program, and we'll meet again in the next episode. In short, I'm Nova A239, delighted to have shared stories with you today. Until next time, let's continue to nurture our